Hello there and welcome to Data Visualization with Seaborn crash course. By the end of this course, you will have gone through the following core concepts, being able to understand the basic structure while it comes to creating visualizations with Seaborn. You will have also created a few types of plots using the Seaborn library. The learning methodology that we are going to be using in this crash course is one where we learn from examples and then you can be able to work on, say, challenges. However, for this particular crash course, there is a notebook that will have only the examples that we're going to be going through. So if you would like to go through now that particular those particular examples that we're going to be working with, be sure to um, follow the link which is in the practice section. And after that, if you feel like you would want to go through some more challenges and also get a project at the very end of this course, you could always follow the link to the full course that we have shared in the description section. The prerequisites courses for this particular workshop is the Python Basics for Data Science course, crash course, the data wrangling with Python crash course, and the data visualization with matplotlib crash course. After this particular crash course, you should now continue to the next course, which is going to be on data analysis with Python. So that's it with regards to our introduction on the structure of this session of the crash course. So let's get started. So once you have been able to follow the link with regards to the practice notebook, you will end up in this particular page where you're going to see what looks like a notebook. A notebook is simply an environment that allows you to put your analysis and run code all together. And the idea is that we're going to be using this particular notebook, which is hosted by Google, and it's on the Google Collaboratory platform, and you're going to be running your code in the cloud. And this is going to allow you to be able to share with others your code, and also to be able to run your code in a server that is independent of your local machine. So that's a bit about the practice notebook that we're going to be going through. Now, when it comes to the Seaborn library, just to give you some introduction, some quick introduction, the Seaborn library is one of the many Python libraries that you will come across when you're working with the Python programming language, especially for data analysis and data science. And this library relies on the matplotlib library, hence the reason why you need to go through that session. And the idea is that it provides you with extra functionalities or functions that would allow you to explore your data set even further. In addition, it also allows you to be able to perform some manipulation when it comes, well, not really manipulation, but create plots which are a bit different than what matplotlib will be able to create. So yeah, so let's get to go through now our session. So the first thing that you do once you get this notebook is to go to File, then save a copy in Drive, and you should be able to get a copy of this notebook that you can be able to edit. So once you are on that particular page notebook, you click on connect, and it's going to connect automatically to a server that is going to be running your code. Then once that has connected, we are now going to go through the different sections. So the first thing that we do when it comes to working with Seaborn is importing Seaborn, which is a visualization library, and we're going to import it, and it's going to use SNS as the name that you're going to be using in any code to refer to Seaborn. And then we're also going to import matplotlib, which, as mentioned, Seaborn heavily relies on matplotlib. We then also import NumPy for scientific computations, as well as pandas for data manipulation purposes. So functions with regards to, say, data manipulations, data manipulation will come from pandas, scientific computations from NumPy, basic libraries, basic functions for plotting, matplotlib, as well as Seaborn. All right, so the basic structure, you're going to learn about two methods. The first method is what we are going to, well, the second method, we will see what method we are going to be using majorly, but we're actually going to be using the first method. The methods that we're going to be using in creating visualizations later onwards. So assuming we wanted to create a simple line plot or line chart or line graph, we would have, first of all, to define these two data sets, then define the size of our plot or figure, that is the size of our visualization. Then later onwards, well, there's a difference between figure and also axis, but we'll come to learn that in a bit. But here we define the size of the entire space that will contain our visualization. Then we render our plot. The first line shows you how you can do it using, you can render a line plot, or line chart or line graph using matplotlib. And this is the other way that you can be able to do, and it's using Seaborn, where we use the Seaborn's line plot function to define how we render our plot. And simply here we are using the DA salary dataset and the age data set. So this is going to, the age will be on the x-axis, and on the y-axis we're going to have the salary. The line graph will have a blue color, and the label that is what will appear on our legend will be the A salary. Then we store all this in this particular variable, and we now are going to be styling again this particular plot that we have created by using these functions. So set title, set x label, set y label, adding a legend, and also displaying the plot. There's a mix of matplotlib, as you can see, as well as some Seaborn. So what has happened here is that we have not run our code. So we need to run the prerequisites here to install our libraries. Then once we do that, we can run this particular code, and you can see that we have been able to create our line plots. Then later onwards, we can be able to add another data set for comparisons. If we had a salary data set, this is how we are able to do that. We can be able to define the data set, set the plot size, then include a second line plot, then be able to plot. So this is also another method that we can be able to use while it comes to plotting our graph. So all right, so just something I was checking. All right, so it should be good to go. So when it comes to as you might have noticed, there's a slight difference in what the approach that we took here, where here we are actually referencing matplotlib, but when it comes to rendering our plot, we are using Seaborn. And in our case here, we're actually using Seaborn functions to tweak our chart and add a few attributes, as well as render the plot. All right, so if you run this, we should be able to see two plots that you see here. So in our case here, we have title, x label, y label, and also legend, which has matplotlib's functions. Um, Same case with the show, but when it comes to rendering the plot, we're using Seaborn, which is the line plot Seaborn function. All right, so the next method requires us to just get a sense of what's actually happening behind the scenes. So we actually, when we plot, we're actually working with two objects. There's the figure object, which tends to act like a container for a graph. And you can think of, you can have a figure object with many graphs. But now in terms of in the context of programming, Python programming, we use axes to represent the individual plots, the individual graphs or charts. And we would be defining, initially we would be defining the figure object and also the axis objects, and be able to apply functions, individual functions to those objects. So for example, we can define our data sets, the two data sets, age and DA salary. Then we can be able to define those two, first of all, two objects, the figure and axis objects, then render our plot by simply using the line plot function, and that's from Seaborn, and use, of course, SNS as mentioned, that refers to Seaborn. Then define the data set that we're working with. Then of course, we do not necessarily have to say X and Y, but in terms of defining them, but you could always define them if the defaults X and Y do not turn out to be the defaults that you'd want to work with. Then define the color of our line graph and also the legend. So if we show this, we should be able to see our line plot, which we use this other method where we define the figure and the plots. And this method allows you to be able to also create multiple plots within one particular figure. So if you wanted to create a second data set for comparison within the same axis, not axis, within the same figure, then we can be able to say DA salary, then get figure. So we define our figure and axis objects, then render the plots using still Seaborn, Seaborn's line plot functions here and here. Then add a title and x-axis x. So we're using ideally here Seaborn's functions for creating a title and x and y labels. If we run this, we should be able to see that we have we have one particular axis and one figure. So yeah, if we wanted to have two axes within one figure, so having another graph on the right side in addition to one on the left, we can be able to do that by simply defining that in our code by simply say get figure and axis object. So we define the size of our figure by saying want one row. Here we have one row and one column, but we want one row and two columns. So and also the size, we've defined the size. So once we have already defined that, we can then render our plots. AX1 would represent the first plot, which will be the first axis, which will be on the left, and AX2 will represent the second axis, which will be on the right. So within our line plot function, we can be able to define that we are actually going to be, plotting this particular line plot, the first line plot in this first axis. So AX then square bracket 0, it means that we actually using, it refers to the first axis. AX square brackets then 1 refers to the second axis. Then we can be able to label and add a title to our individual axis, as you can see here, where we are actually referencing the individual axis or the line plots. So if we show this, we should be able to see we should be able to see two axes in one figure. So a figure that has two axes, which you can see here. All right, so this can also be achieved in matplotlib. If you go through the matplotlib course, you will be able to see that this has also been achieved there. Right, so let's now create a few examples or plots using Seaborn. And a bar chart is the first plot that we're going to create, and it's a type of visualization that presents categorical data with rectangular bars with, of course, lengths and heights proportional to the values they represent. We'll go through a few examples. So assuming that we wanted to create a vertical bar chart that describes the distribution of cake sales for a bakery, then we first of all define our data, the data that we're going to use. We would define that we want to use, say, this data set, cakes. We define the cakes, well, the category. So the categories within the cakes lists. And also, we do so for the sales. And also, again, once we have done this, once we have defined the two lists, we can then be able to store them in a data frame. Now, Seaborn allows you to work with data frames as opposed to matplotlib, which you can use lists which you can work with lists. But when it comes to Seaborn, you are able to work with data that is in tabular form and that is in the form of a data frame. So what we do here in our third line of code is that we save these two lists within our data frame such that we are going to be having records that will represent cakes and also the sales. Then we render our vertical bar chart, and you can be able to do that by simply using the bar plot function and giving the parameters, data parameter x and y axis parameters. And for data parameter, use cakes df, and for x parameter, you define what you want to have on the x-axis, which will be our categories, and same case for our y-axis. Then we tweak and label our axis, and we can do so, or plot, and we can do so by, say, first of all, we would want to have our categories rotated at a 45-degree. And over here, we would want also to define Y label as well as the title. Then we show the plot. If we run this, we should be able to see that we have a plot that will appear as shown. So this is our plot that we have created through the use of the Seaborn library in conjunction with matplotlib. So as mentioned, you can't be able to, yes, you can be able to use Seaborn completely, but matplotlib makes it also a whole lot easier. All right, so if we wanted to render a horizontal bar chart, here we rendered a vertical bar chart, and if we wanted to render a horizontal bar chart, we would simply swap the values that we assigned to the parameters x and y. So in our initial values, we said x will have the cake's value and y will have the sales value. But when you look over here, x has now sales values and y has cake's value. That's basically it. That's what we need to do, and then later run this and we should be able to get a plot. That's the plot. All right, so as you've seen here, we were using two lists, so we transformed our lists into a data frame form. Then we then we passed that data frame to our Seaborn function. We can also be able to directly read data from a data frame through the use of Seaborn, and we are now going to see that in the next example, where we are going to import this tips data set from that URL that you see there, and we're using pandas to do that. And what we have here is the first 5 records for the 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 first 5 records for this particular data set. So once we do this, we can create a summary table. Say, what if we wanted to create a bar chart that shows days and the total bill for each and every days? Running this should give me this particular table, summary table. So we just use group by pandas function to be able to come up with this summary table that you can cover in data wrangling with Python course, or even you could also cover, no, actually you actually cover this in data analysis with Python course, which is the next one. So, and being able to also work with also pivot tables as well as, yeah, pivot tables, but you could also work with also cross tabs. But that's out of the scope of this session. Yeah, so once you have this summary table, you can be able to pass it just the way it is to your bar plot Seaborn function, and this will just take the data set as it is. Then you define what you'd want to have on the x-axis of the plot that you're creating and on the y-axis. And then, boom, just tweak and label and display your plot. And this is what we are going to get. So you can see that we have a plot of bill for the days of the week. All right, so now, as mentioned, the full course of this crash course has challenges that you can work on, and these would serve as a really good way of ensuring that you have grasped the learning outcomes or the concepts that we have learned. So if you are interested in going through the challenges, be sure to have a look at the crash course link that has been shared in the description section. All right, histogram. So a histogram visualizes the distribution of data over a continuous interval or certain time period. So for this particular case, we are going to be using Seaborn to create a histogram. So the first example tells us that we need to create a graph that shows the frequency distribution of the height data set, which we have been given here. We can define our beans that we want to have on our histogram, and then after preparing our data set, we can then be able to render our plot through the use of Seaborn's displot function, which will create the histogram that we need. We pass the height dataset and also the beans dataset. You do not necessarily have to, you do not have to add the beans dataset. It can be created by default. However, it's usually good to customize your visualization for the purpose that you're working with. So we would want to have our histogram have beans coming, which have beans which have the following definition. All right, so if we run this, we should be able to see our frequency distribution of that particular data set that we're working with. And as you can see, this is what we have, which is a bit more polished than what we had been able to plot using matplotlib in the other crash course. So hence, Seaborn comes with its own aesthetic side of it, which is quite useful. All right, the second example, so here we just simply used a list, but we can also get a list of values from a data set by simply, first of all, let's first of all import our data set, but here we would want to display this frequency distribution of the overall variable in the FIFA data set. So we can have a look at our data set, but the overall variable is this one, and we would want to create a frequency distribution of that variable. So what we are going to do is we are going to fetch that particular data set from our already imported data set, and we store it in overall, and then use the displot function and pass it the parameters that we've defined here. We would give the dataset the FIFA DF overall, beans, we also define that, and KDE. So KDE is the line that would also help you to visualize the distribution. If you turn it to be true, it will show you that line, which we are going to see. If you turn it off to be false, then it's going to be false. So if we run this, we should be able to see that particular line. So running this, so yeah, so you can see the distribution line. It's actually what is referred to as kernel density. All right, so you can also, again, as mentioned, if you need some challenges, could always have a look at those challenges. So this is just another challenge that you can be able to do. All right, nonetheless, let's continue to scatter plot. So scatter plot is a type of visualization that can be used to detect if a relationship or correlation exists between two variables. And in our case, we are going to create a scatter plot using Seaborn. So create a scatter plot to describe the relationship between the two variables. So we have X variable and Y variable, which have their data stored in each and every in either of these variables. And what we do is that we would then store these two pieces of data set, these data sets in a data frame. Then we would pass that data frame to our Seaborn scatterplot function, and a data would reference the data frame that we've created, and we define what we would want to have on the X and Y axis. Then we tweak our chart, scatterplot, and label it, and also display it. So in our case here, we can be able to say that as the X variable values increase, the Y variable values also increase, because there's a linear relationship that we can see from the scatter plot itself. You could even draw a straight diagonal line in between the plots, and that would also help you to see that actually the relationship is actually true. If we had points which were scattered all over, and we would not be able to create a diagonal line, or a diagonal line between the points, then it would mean that we wouldn't have that relationship, or the relationship would actually be a weak one. All right. So the second example here, we only used data from two lists. Let's now work with data from a data set that we will import. So we have this country data set, and we would want to create a scatter plot to determine whether population and income variables are highly correlated, which would translate to whether those two variables have a a relationship, or have so whether those two particular variables have any sort of relationship between them. So this is the data set that we've imported, which contains just information, demographic information about countries, just different countries. So the first thing, we've prepared our data set, then we render our plot, just defining the size of our plot. Then our scatter plot, we use the scatter plot function and pass it the data frame that we're working with. Then we define the X and Y the X and Y axis in terms of which variable goes where. Then we introduce a third dimension into our plot using the hue parameter, and this will also introduce some sort of some other meaning within our scatter plot. We will get to see that. We tweak and label our scatter plot and display it. So within our scatter plots, we should be able to see that we actually don't have any relationship between the two variables, because there isn't a linear relationship that we can say that we see, because if you were to draw a diagonal line, actually the points are all scattered, so really there isn't. But if you are to use something like correlation coefficients, you'd find that the two variables have actually a weak correlations. It could be really, really tiny correlations. So there might be a relationship, but it's really, really, really small. The hue component, the hue parameter actually categorized our points into continents, into a category. All right, so the last type of plot that we're going to create using Seaborn is the pair plot. So we use a pair plot to get the relation between each and every variable present in the data set. So a pair plot would simply give us, say, would help us be able to visualize all the variables, the relationships between all variables within our data set, and it also give us some idea of the distribution for all the variables. So here we have three variables, x, y, and z, or z. Then what we do is we put those three data sets into a data frame, and then we render our pair plot through the use of the pair plot function, and we show. If we are able to run this, if we run this, we should be able to see a pair plot which will contain visualizations, scatter plots, and histograms. So on the top left, we can see that we have a histogram that represents the distribution, the frequency distribution of the x variable. The middle distribution, the middle chart shows us the distribution of the y variable, and on the bottom right, far right, we have the distribution or histogram of the x variable that just describes the distribution. So of the values within that variable. So on the other hand, we have these other different plots. We have scatter plots, which, excuse me, we can be able to see that we have, say, the second top scatter plot so the second at the very top, the first row, the second plot, you can see it's a scatter plot between x and y variables, and this shows us that there's those two variables are strongly correlated. The same case on the far end, or the first row, there's a scatter plot between the x variable and the z or z variable, and you can see that those two variables are highly correlated. So you can see that a scatter plot just helps us to visualize variables from a macro level, and this is useful in cases where you'd want to visualize many variables. So again, assuming that we wanted to work with a pair plot function for a bigger data set, and this would take effect, the pair plot function would take effect on values on variables which have numerical values. So in our case, continent and country would not be considered. So if we were to render this plot, we should be able to see now the relationships between all those particular variables. But the year 2020 we would also need to exclude that, because it seems like it's more of a categorical variable. So this is also another scatter plot that we can be able to work with. I think what is mentioned here, so the first row and the first column don't really make sense. Before we even plot this particular plot, we would need to delete to exclude that particular column. That's the year column. That way we are able to remain with the three variables, that's life expectancy, income, and population, and compare some relation and determine the relationship between those two variables, those three variables. But you can see we really don't have any variable with a high with a strong relationship. The one that comes close, but it's still not a really strong relationship. That's the two variables with some relationship, though not strong, are income and also life expectancy. So yeah, so that's it with regards to this course on Seaborn with data visualization with Seaborn. Hope you learned a lot. If again you're interested in going through the challenges, be sure to go through the link which we've shared in the chat, not in this, in the description section. And within that particular course, you will be able to go through more challenges. There are more plots like the heat map, there's a box plot, as well as other plots that will come in handy when you're working with Seaborn. And there are also more examples which you will find there on how you can be able to apply Seaborn when it comes to your data science projects. The challenges which have been provided will also have solutions. So be sure that once you work with the challenges, there will be a place where you can be able to grade yourself and know whether you were able to achieve what was expected. In addition, there's a project at the very end. It's common that whenever you learn a new project, it's advisable that you practice what you have learned, and we've provided a project that will allow you to learn how to work with Seaborn. So yeah, there are other important links. If you would like to follow us on our platforms, be sure to do that for such future informative courses. You could also like if you know this particular video, also rate and also subscribe if you think you're going to benefit from such future courses. Again, data visualization with Seaborn full course already available. And lastly, if you have questions, pending questions on some of the things that we have covered in this session that you're not really sure about, you can join our Afterwork Data Science community on Telegram, and that link will also be provided. So after this, once you've gone through this entire course, the next course that you can work on is the data analysis with Python course, or you could also go for another visualization course that helps you to fill in those gaps that you might have had you might have still when it comes to data visualization. Maybe I'm working with Plotly, data visualization with Plotly, or working with Power BI or Tableau or D3.js or whatever whatever data visualization course that you think you would need. So that's it for this video or for this course. See you in the next course.